Hello everyone. Welcome back to my YouTube channel. My name is AVOGADRO'S. Today we are going to be looking at a very important topic in chemistry, which is called gas laws. The gas law is a very important topic in chemistry. It's going to be 8 series package. Make sure you stay tuned to the 8 series of this gas law. Okay, I'll be starting with Boyle's law, Charles law, general gas equation, ideal gas equation, that law of partial pressure, Avogadro's law, Gilliard's law of combining volume, and Graham's law of diffusion. Ideal gas too. Okay, all right. So let's start with gas laws. All right. Now, the behavior of gas to changes in conditions. The state or condition of a gas can be characterized by the following properties. Number one properties of this gas law is pressure. Number two, volume. Number three, temperature. All right. When any of these properties changes, the state of the gas also changes. The physical behavior of gases are quite different from those of solid and liquid. The behavior of gas were investigated by the scientists like Boyle's, like Charles, like Graham's, and like Dalton's. These are scientists that actually work on gas law. They describe the physical behavior in different gas laws. The gas law can be explained by the kinetic theory of gases. In order to do this, the theory has to make some hypothetical assumptions based on situation that is not real but might happen, or it might be postulates about the real gases, assumption that completely describe a perfect or ideal gas. Let's dive into the first aspect of this gas law. So we'll be looking at a subtopic that I've called number one, I call it Boyle's law. Boyle's Boyle's law. Okay. Now by definition, number one, let's look at definition. We're looking at the definition of the Boyle's law. Objectively, by the end of this lesson, you should be able to, students should be able to, number one, define Boyle's law. Number two, be able to state mathematically the formula of Boyle's law. That's number two objective. Number three objective is for any student to be able to draw and represent a Boyle's law graphically. And number four is be able to calculate, okay, solve problems under this particular law called Boyle's law. So definition, by definition, Boyle's law states that the volume of a given mass of gas is inversely proportional to its pressure, provided that temperature remain constant. I go again. The volume of a given mass of gas is inversely proportional to its pressure, provided that temperature remain constant. So let's look at it mathematically. So mathematically, we discover that volume is inversely proportional to what? To pressure. T is constant. Remember, my introduction of the gas law, we look at three parameters: look at volume, look at pressure, and we look at temperature. All right. Now, volume inversely proportional to what? To, let's say, volume equals to 1 also K 1 over what? P. Volume equals to K over P, while K equals to PB. All right. Now, if I vary the value of the volume, both the volume and the pressure, I'm going to have something like P1, B1 equals to P2, V2, which form the formula for Boyle's law. All right. What's the meaning of P1? The P1 is initial pressure, while the P2 is final pressure, while the V1 is initial volume, and the V2 is what? Is final volume. Now, what's the meaning of this particular formula? Now, looking at this representation I'm drawing inside this box, we discover that pressure, initial pressure, which is P1, initial volume, as pressure is increasing, okay, the volume is what? Is decreasing. So let's look at it. Can you see? Can you see? Can you see that? As my pressure is decreasing, my volume is increasing, and vice versa. If your volume is also increasing, your pressure will also decrease. Now, what are the graphical representation? Graphical representation. Graphical representation of Boyle's law. Now, number one, you can represent Boyle's law in this direction. Graph from the origin, volume 1 over pressure. You can also represent graph Boyle's law in this direction. Pressure equals to 1 over V. And lastly, you can represent Boyle's law in this direction. Volume, but this one is not going to pass through the origin P. These are the three ways Boyle's law can be represented under graphical method. Now, another thing we need to quickly look at is to see what are the units that we need under Boyle's law. Let's look at the unit under Boyle's law. Okay, units. Standard units. What is standard units? Standard units. P is mm Ag, pressure, you call it millimeter mercury. All right, which is standard at 760 millimeter mercury. D is cm3, okay, or it can also be dm3. P can also be in atm atmosphere, okay, and the atm, the standard atm is what? 1 atm. Call it stp at stp, okay, at stp the standard is what? 1 atm. And another thing I used to represent pressure, we can represent it in nanometer per square, okay, nanometer per square. If you do nanometer per square, the standard for nanometer per square is 1.01 times 10 raised to the power 5 nanometer per square. So let's take note of those units are very important in calculating Boyle's law. So there's a need for us to take some problems. Okay, let's take some problems to see whether we are making progress. Number one, let's look at one SSE questions. Let's look at SSE question. I can quickly wrap up this place. Let's solve one SSE question. The question says, you can see the question on the screen. The pressure exerted by 50 cm of oxygen gas is 500 millimeter mercury. What would be the new volume of the gas if the pressure increases to 750 millimeter mercury without changing the pressure? Now, this question is a Boyle's law question. So we are going to be looking at using this formula that says P1 V1 equals to V2 V2. Now, from the question, we realize that Our P1, okay, our initial pressure is 500 millimeter mercury. Our initial volume is 50. You can check according to the question. And our final pressure is 750 mmHg, while our final volume is unknown. So if you use this particular method or particular formula, let's see what we're going to arrive at. So let's substitute the value correctly. So we have 500 multiplied by 50 equals to 750. Make beg your pardon, 750 times V2. So let's make V2 the subject of formula. I hope you are following me closely to it. Please go ahead and follow me closely. Times 500 divided by 750. If you pick your calculator and you do that correctly, you're going to have your V2 to be 33.3 cm3. Did you get that? Did you get that? Oh, you are following me. So you can put your hands together for yourself. Put your hands together for yourself. It's an SSC question. It's an SSC question. So let's look at example 2. That's example 1. That's example 1. Let's look at example 2. Example 2. Let's quickly check example 2. All right. Example 2. Just take the screen. Example 2 says, if the pressure of 200 cm3 of a gas is half, if the pressure of 200 cm3 of a gas is half at constant temperature, what will be its new volume? If the pressure of 200 cm3 of a gas is half, what will be its new volume? So let's look at it using this P1 V1 equals to P2 V2. Okay, what's our P1? I like to analyze my values before I start calculating. P2 V1 V2. Of course, we are looking for the final volume. We say if the pressure of what I have is half and the volume is 200, is my initial volume is 200. My initial pressure can say, let's say, is 1. Can assume that it's 1. And my final pressure, say half. That's 1/2. Okay. If I'm using 2, that's going to be 1. An assumption because the statement is there. Substitute the value we have. We have 1 multiplied by 200 equals to half multiplied by V2. Let's make to some formula. V2 equals to 1 times 200 divided by 0.5. My answer will be 400 cm3. My second volume is 400 cm3. Did you get that too? Did you get that? If you get that, you can clap for yourself. You are making progress. You are making progress. I hope you are understanding. Okay, let's go to example 3. Example 3. Let's look at example 3. All right. Let's look at example 3. Example 3 says it's a UTME question 22007. 300 cm3 of a gas has a pressure of 800 millimeter mercury. Okay, 300 cm3 of a gas has a pressure of 800 millimeter mercury. If the pressure is reduced to 650, find its volume. Okay, now let's look at it. Now, you're using this formula, P1 V1 equals to P2 V2. All right. Now our P1 from that question is initial pressure and our P2 is final pressure. From the question, the initial pressure from that question reads that is what? 800 mm Ag reduced to 650 mm Ag. What's our initial volume? The initial volume from that question is 300 cm3. 300 cm3, and we have V2. So can we quickly calculate this when we use this particular formula? So let's calculate together. Look at it. Let's substitute respectively the value of the parameters we have. Our P1 is 800 multiplied by my V1 is 300 equals to my P2 is 650. That's a reduction, and my V2 is this. Okay, now make V2 such a formula. We're going to have 800 multiplied by 300 divided by 650. So if you do that in your calculator, we arrive at V2 will give us 369.2 kg. Alright, that's example 3. Let's move to example 4. Alright. I hope you are getting help, you are making progress. Boyle's law is the first law we're treating, okay, in this series. Let's look at example 4. Example 4 is also a UTME questions. Yes, because some of you that are UTME students should have come across this particular question. Alright. The question says the ratio of the initial to the final pressure of a given mass is ratio 1 to 1.5. That's pressure. Okay, that's our pressure. Alright, it says calculate the final volume of the gas if the initial volume was 300 at a constant temperature. Calculate the final volume of the gas if the initial volume was 300 at a constant temperature. So we are looking for V2, but we have our V1 to be 300 cm3. This one is unknown. Of course, the formula to be used again is P1 V1 equals to P2 V2. Alright, now what they are telling us now, the ratio of our initial pressure to our final pressure is what? Is 1:1.5. So in very way I can say my P1 is 1. Alright, multiplied by my V1. My V1 is 300 equals to my P2 is 1.5 multiplied by what? My V2, which is the unknown parameters that I'm looking for. So let me make V2 again the subject of formula. We will have 1 multiplied by 300 divided by 1.5. I have my final answer to what? To be something around 200. Let's divide it. I have 200. I have 200 cm3. At the same time, we can also follow this pattern of solving. If you are not that pleased with that, you can say the ratio of P1 to P2 and volume 2 over volume 1. Your P1 to P2 is 1:1.5 equals to your V2, what we are looking for, and your V1 will be 300. So when you multiply, you have 1 multiplied by 300 equals to 1.5 V2. Okay, your final answer, which is V2, will also give you 200 cm3. Alright, it is the same method. Hope you are making progress. Now, we can quickly move to the next question, just to teach you the different ways of solving questions when it comes to what? When it comes to Boyle's law. Example number 5. The question says, a gas of volume 500 cm3 exerts a pressure of 2 of 20 millimeter mercury, that's 20, what volume will it occupy when the pressure is number 1 doubled, number 2 reduced by half, number 3 by half of the initial pressure, and number 3 tripled. This question is so interesting. Hey, come with me, let's solve it together. It said a gas of volume 50. Okay, this is the P1 V2 is equal to P2 V2. Right. So this one is going to be double. That's 20 multiplied by what? 2, giving me 40 mmHg. Alright. So let's quickly calculate it. Substituting the value, my P1, which is 20, my V1, which is 50, equals to my P2, which is 40, multiplied by my what? V2. So my V2 equals to 20 multiplied by 50 divided by 40. 0, 0, 4 here, and 4 here, 5. That's 25. So for this question, when my pressure is doubled, my final volume will be 25 cm3. Alright, now the next one, we are not done with our question, so we are going to continue. The next question says, what of at when my pressure, when the pressure is reduced, when the pressure is reduced, pressure is reduced to half the initial pressure, or let's say initial value. Let's reduce to half of its initial value. That is, the P1 we had before was 20. Okay, half of 20 will give us what? Divided by 2 will give us what? 10 millimeter mercury. So my P2 is going to be what? 10 millimeter mercury. My P1 is still 20. Okay? Alright? Millimeter mercury. My V1 is still 50 cm3. My V2, that's what I'm looking for. So I can use the same formula to calculate. Now, P1, my P1 is 20, and my V1 is 50, equals to my P2 is 10 times V2. My V2 would be 20 multiplied by 50 divided by 10. You can see that. What do I have there? I have 100 cm3 as my what? As my final volume when my pressure is half of its original initial pressure. Okay, lastly, the third question on this particular question: what if when your pressure is tripled? Okay, let's say at tripled initial pressure. The initial pressure, this is P1, is 20 multiplied by 3, giving was 60 millimeter mercury. So my P2 is what? 60 millimeter mercury. Okay, my V1 still remains the same, 50 cm3, and my V2 is the value I'm looking for, but this time at the triple initial pressure. So let's look at P1 V1 equals to P2 V2. P1 is 20 multiplied by my V1, which is 50, equals to my P2 is now 60 multiplied by V2. So my V2 equals to 20 multiplied by 50 divided by 60. 0 cancels 0. 3, 2 here, 3, 2 here, what? 10. So when you do that, what are you going to have? Okay, you're going to have something like 50 divided by 3, give you 16.67 cmq. So my final answer for my V2 is what? Is 16 points cmq. Lastly, on this series, okay, let's look at the last question. I wish I can give you this one as a classwork for every student to quickly build. Alright, I can give every student this. So the last question, let's say classwork. Let's say classwork. Try it. You can pause the video for a while and try this question. Classwork. The question, see, look at the question. The initial volume and pressure of a given mass of a gas is V and 3P respectively. What is its pressure? Its volume is increased to 2V. The initial volume and pressure of a given mass of gas is V and 3P respectively. What is its pressure if its volume is increased to 2V? Can pause the video and solve. By now, I believe you have looked at the question. So let's quickly solve together. So our initial, using the same formula, P1 V1 equals to P2 V2. Our initial volume or pressure, our initial pressure is 3P multiplied by our initial volume V equals to our final pressure, that's what we are looking for, and my final volume, which is 2V. So make P2 to solve the formula, we're going to be having 3P times V over 2V. V can easily cancel V. So we have P2, that's final pressure, equals to 3P over 2. Which final answer can give you, divided, can give you P is equal to 1.5 P. Alright, thank you for watching this series of advanced law, which is much law. Next I say what in the next one, which is called CHARLE'S law. Subscribe. Thank you. God bless you.